So this video is on trigonometric functions and what we will call the unit circle. All right, so the unit circle, again, we're now talking about trigonometry in the coordinate plane. Okay, so if we look at an angle in the coordinate plane, we want to get some information from it. All right, so what we're going to talk about first is an angle. So this angle theta, right here. All right, it's right, this is where we're looking at it. So the angle theta is what's called a standard position. Standard position means that the initial side is on the 0 coordinate, or the 0 where 0 degrees, okay, on the x-axis, and then xy is a point on the terminal side. Right? If you remember, the formula for a circle is x squared plus y squared equals r squared. So if you remember that from geometry, and a little bit in Algebra 2. Actually, if you're taking Algebra 2 now, we're going to talk about that in December. But that's the equation for a circle. Okay. The 6 trigonometric functions are defined as follows. So first of all, let's notice something about this angle. Okay, this triangle. So if we talk about the x and the y, okay, so here's the x, here's the y, and you don't need to write this down, it'll get kind of confusing. R is going to be the hypotenuse. Okay, so R is going to be hypotenuse in all of these. All right, so let's talk about what sine would be. Let's talk about cosine. All right, let's talk about what the tangent of theta would be. And then we'll talk about the cosecant of theta, the secant of theta, and the cotangent of theta. And we'll just talk about those as inverses of sine, cosine, and tangent. Okay, so we talk about the sine of theta. All right, the sine. Remember, sine is opposite over hypotenuse. So we talk about the angle. Okay, y is opposite that angle. Okay, so y is opposite that angle. So, and the hypotenuse is r. So the cosine is going to be x over r. All right. And then the tangent will be opposite over adjacent, which is y over x. And let's make a note here. X cannot be 0. Okay, because if x is 0, then I'd be dividing by 0, and you can't do that. So then these would just be the reciprocals. So r over y, and now y can't equal 0. And then r over x, and again, x can't equal 0. And cotangent would be x over y, and y can't equal 0. So what we're going to do, we're going to use this to, if I give you a point on the terminal side of the angle, so if I give you this point, what would be sine, cosine, and tangent, and then the reciprocals, cosecant, secant, and cotangent. All right. Note, all right, that the radius would be the square root of these, and I get that right from this equation. Okay, so I get that right from that equation. I just do the square root of both sides, and I get that r is x squared plus y squared, or the square root of x squared plus y squared. All right, so now we're going to do an example. I'm going to give you a point, and we're going to find all those things. All right, so we're going to say let 5, negative 3 be a point on the terminal side of angle theta. And I don't know if I told you guys, but we use theta a lot for to talk about an angle. Okay. All right. What we're going to do is find the 6 trigonometric functions of theta. of theta. Okay, so the first thing we need to do, we have x. All right, x is my x coordinate, 5, and then y is my y coordinate, -3. So if we kind of look at that in the coordinate plane, although technically we don't really need to know it, but we talk about that in the coordinate plane. So here's my coordinate plane, and then I would say the 0.5, -3, we're talking about down here. Okay, so 5, -3 would be, somewhere right there. So we're talking about this angle here. Okay, we're going to find the sine, cosine, and tangent of that angle. We don't know how many degrees that angle is. We can find the sine, cosine, and tangent. And actually, I guess we could do the inverse if we wanted to and figure out what the angle is if we wanted to. All right, so what we need to do here, we need to find r. Okay, so r equals, again, x squared, the square root of x squared plus y squared. So let's do that. R equals the square root of 5 squared plus -3 squared. Notice I put that in parentheses because if I don't, when I put in the calculator, it will give me -9 instead of 9. So I want to make sure that -3 squared gives me a +9. All right. Let's see, 25 plus 9, which is 34. I don't think there's a perfect square that goes into 34. 4 doesn't go, 9 doesn't go, no. Okay, so no perfect square goes in the square root of 34, so that is simplified. Okay, that's just simplified as much as possible. So now I can find the sine, cosine, tangent, cosecant, secant, and cotangent of that angle. All right, so let's do that. All right, so sine of theta. All right, I'm just going to copy from the top is y over r. Cosine of theta is x over r. And then tangent of that angle is going to be y over x. And then I'll just do the reciprocals for cosecant, which is r over y. Secant. I guess we can go ahead and write that. It won't hurt. Secant, r over x, and then cotangent, x over y. Sorry, that took me a second. Okay, so let's see. We're going to have -3 over the square root of 34. We can't leave a square root at the bottom, so I'm going to rationalize it. All right, so it's going to give me -3 square root of 34 over 34. And that is hard to read. Let me fix that a little bit. So -3 square root of 34 over 34. X is 5. Write that over the square root of 34, which is r. Rationalize it. So I get 5 square roots of 34 over 34. Perfect. All right, and then tangent is y over x, -3/5. All right, cosecant, secant, and cotangent, we just did the reciprocal, so this would now be square root of 34 over -3. I'm going to put the negative on the side there, or on top of the 34 if you want, or on the side of the 34, not on top. Just put it on the top. All right, and then this would be square root of 34 over 5, and this would be -5 over 3. So again, it's just the reciprocals of sine, cosine, and tangent. So now I know the sine, cosine, and tangent of this angle here that I drew. So now we're going to talk about a very specific circle called the unit circle. And we're going to typically now be in the unit circle. So it's called the unit circle because we're going to talk about the circle x squared plus y squared equals 1. So I have a center at 0, 0, and my radius is 1. Okay, so my radius is always 1. All right. So what we want to talk about is then what would sine of theta and cosine theta be in those instances, and how can we use that to find the trigonometric functions of an angle on the coordinate plane. Okay, not when we're given the ordered pair like before, but when we're given the degrees. Okay, so let's say, let's see, so we'll talk about sine of theta first. So remember, sine of theta is y over r, but our radius is 1. So sine of theta is always going to be y. So if we know what our y coordinate is going to be, that's what sine of theta will be. If we're in the unit circle, again, we're talking about a very specific circle when the radius is 1. How many degrees am I going to be on that circle? Cosine of theta is going to be x over r, which is x over 1, which is going to be x. I don't like that y. All right, so what are you talking about, Ms. Collier? So let's actually draw this out. Let's actually do an example, and then we'll go into more specifics to find a bunch of different angles. All right, so let's say we want to find the 6 trigonometric functions of 180, all right, 180 degrees. Remember, that's pi. Okay, so let's look at that angle real quick. Let's look at it. All right, so here's my coordinate plane. Here's my initial side, and then my terminal side will be right here on 180. So we're talking about this angle right here. So if that's the angle we're talking about, the coordinate here, all right, we know this, we're going out by 1, all right, because that's my radius. My x coordinate is -1 because I'm out 1, but in the negative side. All right, so this is the point -1, and then my y is 0 here, -1, 0. So there's my x and y for that. All right, so I can find sine, we can find cosine, we can find the tangent, and then we're going to find the reciprocals. Cosecant, secant, and cotangent. All right, so I'm in the unit circle, so I'm y over 1, so it's just -1. That's a lie. That would be x. So I am 0. My y coordinate is 0. Cosine is my x coordinate, which is -1. And then if you remember, tangent is y over x, so 0 over -1, which is just 0. All right, so now we're going to do the reciprocals. The reciprocal of 0 is undefined because I'm 0 over 1. I can't be 1 over 0. Whoops, I didn't mean to put a equal sign. That is, the reciprocal would be 1 over 0. Can't be over 0. So we're going to put the cosecant in this case would be undefined. And in fact, in the calculator, if I try to find the cosecant of 180 degrees or pi, it would give me an error message. The reciprocal of -1, -1 over 1, I flip it, it's still -1 over 1, or 1 over -1. And then again, I can't find the reciprocal of 0, that's undefined. All right, so now we want to talk about, now how can we use this information to find almost any angle in the unit circle. So first thing we want to talk about before we start talking about a bunch of degrees and stuff we have to memorize, we're going to talk about reference angles. All right, so what we want to talk about is what's called a reference angle relationship. We want to find reference angles of any angle. because it lessens the amount of things we have to memorize. So we want to keep our angles in terms of quadrant 1. So if let's just remember what different quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4 of the coordinate plane. Instead of having to memorize all the degrees in quadrant 1, all the different measurements in angle 2, 3, 4, all of those sine, cosine, and tangents, that's a lot to memorize. What we like to do is use quadrant 1 as a reference for the rest of the angle. So I can say, all right, if I know it's going to be in 1, then all I have to do is really change the signs a little bit to figure out what's quadrant 2, 3, and 4, because the coordinates in 1 are the same as the coordinates in 2, 3, and 4, just with different signs. So first, let's talk about how we find a reference angle. So we want an angle. If we know our angle is in quadrant 2, and how do we know that? We got to think about, again, our angle. So like this is where 0, 90 degrees, 180 degrees, 270 degrees, 360, and we can also talk about that in terms of radians. Sorry. So again, this would be 2 pi, this is pi, this is half a pi, and this is 3/2 pi. Okay, so we can use that. Okay, what angle am I in? If I'm 200 degrees, I'm somewhere between 90 and 180. So I'm in, oh sorry, if I'm 200 degrees, I'm somewhere between 180 and 270, so I'm somewhere in quadrant 3. Or if I'm 100 degrees, I'm somewhere in quadrant 2. All right, so we're going to figure out what quadrant we're going to be in, and we're going to use that then to figure out what our reference angle would be in quadrant 1. So if I'm between 0 and 90, I'm good. I am a reference angle. I am a reference angle. However, if I'm in any other quadrants, I want to find it. All right, so let's look at quadrant 2. So if this is my angle, my reference angle is going to be here. Because if you remember back at the beginning when I said x and y, I did y and x like this when I squared them. All right, so there's my reference angle here. Okay, my reference angle is going to be how many degrees that is. And the way I get that is, if I know this is 180, it's 180 from all the way across, I subtract my angle from 180 and I get what this little angle is. All right, so I take 180 and subtract my angle, and what's left is this reference angle. Okay, or in turn, I can subtract from pi, because pi is the same as 180 degrees. So I can also subtract it from pi. If I'm in quadrant 3, here's my reference angle. Okay, there's my, so I'm going to take 180 from that angle. So here's my angle. If I subtract 180 degrees from it, I'm left with this angle, which is now my reference angle. Okay, how many degrees is that? Okay. Reference angles are always less than 90, by the way. Or in turn, the angle minus pi. If I'm in quadrant 4, all right, here's my reference angle. All right, so to do that one, here is my angle. If I take that angle from 360, I'll get what's left over. So here's 360 all the way around. If I subtract my angle from it, which is here, then I'm left with my reference angle, which is there. So let's do that. Let's practice finding some reference angles of some angles. All right, so let's do some examples. All right, so we're going to find the reference angle of 300 degrees. We're going to find the reference angle of, actually, let's write this. Let's write theta equals 300 degrees. Number 2, we're going to find the reference angle of when theta is 3 pi fourths. And then we're going to find the reference angle when theta is 210. So the first thing we have to do for any of these, figure out what quadrant my angle's in, the actual angle line is in, and then we can use that to find our reference angle. Again, a reference angle is somewhere in quadrant 1. All right, so 300 degrees. 300 degrees is between 360 and 270. All right, so I am going to be in quadrant 4. Okay, because I'm somewhere between 270 and 360. So I'm going to be in quadrant 4. All right. So the rule for that is 360 minus theta. So we're going to call it theta prime. Okay, is our reference angle, theta prime. That's what that little tick mark is, a prime. It's like a quote, like part of a quote. What do they call that? It's not a quote. You put in contractions. Oh crap, I can't remember. Anyways, so 360 minus 300. This guy's reference angle is 60 degrees. So if I know the sine, cosine, tangent, whatever, is 60 degrees, I then can just switch the signs a little bit, and I can find that now of 300 degrees. And we're going to practice doing that later in the lesson. All right, 3/4 pi. 3/4 is bigger than a half, but it's less than a whole. So I'm going to be in this quadrant here. Okay, I'm going to be in quadrant 2 because I'm somewhere between a half pi halves and pi. So I'm in quadrant 2. So the rule for that is going to be, let's see, quadrant 2, theta prime is going to be pi minus 3 pi fourths. All right, pi is 4 over 4 because it's a whole 4 over 4 minus 3 over 4 is 1 over 4. So 1 pi over 4. So that's his reference angle. So that's his reference angle. And then finally, reference angle for number 3. I'm 210 degrees, which is somewhere between 180 and 270. So I'm in quadrant 3. So the reference angle theta prime is going to be, theta minus 180. So this reference angle is 30 degrees. All right, so reference angles. Why do we care? Why do we care about reference angles? We care about reference angles because it gives us a chance to use special angles to find to memorize the trigonometric values of almost any angle or any important angle in the coordinate plane. Okay, so here's the table we are going to memorize. All right, I still have this memorized from when I was in high school and I took trig because you use it so much. I use it in calculus. When we go to graph, sine, cosine, and tangent, you'll need to know this. And you want to be able to get to it quick and not have to always refer back to this chart. Okay, you want to be able to get to it quick, and that's the point of memorizing it. So these come from, if you remember, the rules for special right triangles. Okay, so if you remember the rules from special right triangles from geometry, you'll know where these come from. So we talked about like a 30, 60, 90 triangle. All right, so let's look at that first. I'm going to be over here so you know where these come from. So 30, 60, 90 triangle. All right, if you remember, we put everything in terms of the angle. So 30, we would say, hey, let's say he has a length of 1. The hypotenuse is twice that, which is 2, and this was the square root of 3 times that. So I don't know if you guys remember that. All right, so we can use that to find the sine, cosine, tangent, and then the reciprocals of 30 degrees. Okay, so this was the rule we talked about in geometry. Okay, that if this was 1, the hypotenuse was double that, and then the other leg was the square root of 3 times that. All right, so sine of theta, and theta is 30 degrees, and that's where we are, is going to be opposite over hypotenuse. All right, so 1 over 2. And the sine of 30 degrees is always a half, or pi 6. By the way, pi 6 and 30 degrees, again, are the same thing. Cosine is the square root of 3 over 2. Tangent is going to be the 1 over the square root of 3, and once I rationalize that, would be this. Always true. So the sine of any 30-degree angle is square root of 3 over 2, and then the reciprocal. So this will be 2. This would be a rationalized reciprocal of cosine, and then cotangent would just be the square root of 3. All right, this is a reciprocal of that tangent. All right, so let's go down here to 60 degrees, all right, and fill that in based on this triangle. So now we're going to switch. So now the opposite of 60 was the adjacent to the 30. So now cosine is a half and sine is square root of 3 over 2. All right. Cotangent is now square root of 3 and tangent is now this. All right. And these two are also switched. Okay, because I switched my opposite and adjacent. Okay. Now, 45 degrees. Let's look at the 45 degree one. That comes from a 45, 45, 90 triangle, which if those two 45s are the same, then both of these are the same. So they're both 1. And then this was the square root of 2 because, well, Pythagorean theorem. 1 squared plus 1 squared would be 2. Square root of that is the square root of 2. So now we can do 45 degrees. All right? So the hypotenuse is square root of 2. So this would be, the sine is 1 over the square root of 2, but we need to rationalize that. So you end up this. And the cosine's going to be the same because the adjacent and the opposite are the same angle. This would just be opposite of adjacent, which is 1. And then we'll talk about reciprocals. So this would be square root of 2 over 1, which is square root of 2. Square root of 2 over 1. And the reciprocal of 1 is 1. All right? Again, you want to have, or you're going to memorize these. I would make a flashcard with these on there because your life will be easier if you do. All right, so let's talk about these last reference angles or special angles. These are right on the coordinate plane. All right, so if you know 0 and 360 or 0 and 2 pi, there where x is 1 and y is 0. This is where x is 0 and y is 1. This is where x is negative 1 and y is 0, and then this is where x is 0 but y is negative 1. So now we're going to use that to find all these values. Okay, so again, I just got it from here. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, so that's where I'm getting all that information from. All right, so if you remember, sine is your y and cosine is your x, if you remember for the previous note. So sine is my y, cosine is my x, and then y over x is my tangent. The reciprocals, this is undefined. The reciprocal of 1 is 1, and then reciprocal of 0 is undefined. Okay, now these roles are reversed. Y is 1, x is 0. Right, this is undefined. All right, the reciprocal of 1 is 1. This is undefined. And the reciprocal I get undefined is 0? Ooh, I guess. All right, here, y is 0. X is negative 1. 0 over negative 1 is 0. Now we'll do the reciprocals. Undefined. Negative 1, undefined. All right. Y is negative 1. X is 0. Negative 1 over 0 is undefined. The reciprocal is negative 1, undefined, and 0. All right, so this table, I would make some flashcards and memorize it. All right, so now it's time to pull this all together. What are we doing? We're going to find the any value for the, like I want to find the sine of 240, or the cosine of 60, or the tangent of 300 degrees. How can I do that? All right, so one of the things I want to talk about is what the sines will be. Okay, so first we want to find the reference angle. I guess I should say that. So first we're going to find the reference angle so we can use the chart above. Okay, is that how you spell reference? There's no way. Reference angle theta. Okay, and we're going to find that, guys, from the chart or from our memorize. We're going to evaluate the trigonometric function for theta prime, that reference angle. Okay, so reference angle 60. All right, well then the cosine is 1/2. All right, but we need to worry about the sines, okay, because the sines will change depending on the angle. So let's talk about that. So the last step is determine the sine of the trigonometric function value from the quadrant in which theta lies. Not theta prime, but theta lies. Okay, so let's talk about the quadrants here. This is another thing to memorize. All right, so sine and cosine and all that are always in terms of x's and y's. In quadrant 1, everything's positive because x's and y's are all positive. In quadrant 2, x is negative and y is positive. So our sines will be positive because y is positive. Our cosines will be negative because x is negative. And in tangent and cotangent will be negative because the negative over, or positive over a negative is a negative. In this quadrant, they're both x and y are negative. So sine's negative, cosine's negative, but because they're both negative, tangent and cosine will be positive. A negative divided by negative is a positive. In this quadrant, quadrant 4, x is positive, y is negative, cosine's positive, sine's negative. A positive or a negative over a positive is a negative. So those are negative. All right, so let's do 3 examples. Okay, let's get to this nitty-gritty now. Let's do 3 examples. All right, so let's do 3 examples using this step. So first we're going to find the sine of 240 degrees. We're going to find, actually we're going to do 4 examples, I lied to you. Tangent of 150 degrees. We're going to find the secant of negative 315 degrees. And then the cosine of negative 3/4 pi. All right, so step 1, we're going to find the reference angle. So I got to figure out what quadrant 240 degrees in. 240 degrees is between 180 and 270. So I'm in quadrant 3. And it might not hurt for us to kind of look. All right. At the quadrants while we're here. All right, and we'll do 0, 90, 180, 270. Okay, so again, I'm in this quadrant, so I'm over here. All right, so to find the reference angle for that, when we're in quadrant 3, it's always 240 minus 180. So that's going to be 60 degrees. All right, now I look at my chart. I'm finding the sine of 60 is square root of 3 over 2. Got that right from my chart. All right, so the sine of 60 is square root of 3 over 2. Since I'm in quadrant 3 and I'm doing sine, my y is negative. That is a negative square root of 3 over 2. All right, remember sine, think y's. All right, pick your quadrant, find your reference angle, write down the sine, cosine, tangent, whatever at that angle, and then figure out what your sine will be. All right, tangent of 150, that's going to be in quadrant 2. All right, so I'm in quadrant 2. To find the reference angle in quadrant 2, I do 180 minus that. Okay, I do 180 minus that, and I get 30 degrees. Tangent of 30 degrees, I'm going to look at my chart, or hopefully we'll have that memorized. The tangent of 30 degrees is square root of 3 over 3. In quadrant 2, my x's and y's have different signs, therefore my tangent is negative. So in quadrant 2, tangent is negative. Reference angle is 30, that's square root of 3 over 3 for tangent, and it's negative because I'm in quadrant 2. All right. Now we're going to talk about, what if our angles are negative? So negative 315 is going to be somewhere in here. All right. So remember, to figure out what your negative is going to be, if you have a negative angle, I like to add 360 or 2 pi to that to figure out where I'm at if I'm a positive version of it. So when I do negative 315 plus 360, I'm at 45 degrees, which is in quadrant 1. So I was in quadrant 1. So I don't need to find a reference angle because 45 is a reference angle. All right? And then the secant of 45 degrees is, let me look, square root of 2 over 2. That's not right. The secant of 45 degrees is not square root of 2 over 2. It's the square root of 2. So square root of 2. Tricked you. So if I'm negative, I add 360 or add 2 pi until I get to a positive. Then if I get an angle that is in a quadrant 2, 3, or 4, then I find a reference angle and then do the sine thing. But this was a reference angle. All right. So here's another negative. So I'm going to add 2 pi to this. And 2 plus negative 3/4 is 5/4 pi. All right, so this is pi halves, this is pi, this is 3 pi halves. 5 pi fourths is in quadrant 3. All right, so since I'm in quadrant 3, I'm going to, the rule is subtract pi from it. So reference angle, 5 pi fourths minus, again, we're finding a reference angle because I was not in quadrant 1. So that would be pi fourths, which is 45 degrees. All right, pi fourths is just 45 degrees. The cosine of 45 degrees of pi fourths is square root of 2 over 2. And in quadrant 3, x and y are negative, so this is going to be negative. So, figure out what quadrant you're in. Use it to find your reference angle. Find the sine, cosine, tangent of the reference angle, and then pick your sine. You could check your work in the calculator to see, all right, did I get the square root of 2 over 2? But your calculator won't give you square root of 2 over 2. Okay, you can kind of use it to check. And if you want help with that, let me know. All right, so that's the unit circle and reference angles. A lot to take in, a lot to take in. Let me know if you have any questions.